And of course, some of the benefits that are in the DFT's documents of battery and hydrogen facilities on board are that actually they can be used to overcome perturbation and diversion onto routes that aren't necessarily electrified at the time for whatever reason. So they can actually work to help the system rather than hinder it.
Exactly right. Yeah, it is that again. That's a flexibility that the network is used to with diesel, and the ability to provide it with these new technologies is great.
Yeah. A couple of questions on hydrogen. You mentioned green hydrogen, and I got the idea of it's creating hydrogen from spare carbon-free electricity generation. Generally, why is that important? Presumably, the hydrogen is no different to any other hydrogen. Why is that an important thing for us?
Well, if you can produce your hydrogen from renewable energy, be it spare, by which we mean the energy that otherwise isn't used on the electricity grid. So, for example, a windy and sunny day, but there's no one drawing any power. You've got a surplus. You've got nothing to do with it. So it's called curtailed energy, where the generators are obliged to switch off their capacity. You can use that electricity to create hydrogen. And the point is that renewable energy, whether it's curtailed or generated specifically for the purpose of creating hydrogen or any other purpose, it has no carbon content. And that means your hydrogen has no carbon content. Of course, you don't combust it on a fuel cell train, you chemically convert it, so there's no carbon emission and no toxic emission there. So what you have is from what used to be called the well, which is now, I guess, the wind turbine, to the wheel of the train, you have no emissions. So you have a completely zero emissions cycle, including the translation of the electricity to hydrogen and back to electricity. All of that process is carbon free.
And presumably the spare electricity could be seen as a waste product in a way.
Well, yes, if you're looking at the business case to create a wind farm, you have to factor in the electricity that you could generate but can't sell. What better place to be than knowing you can sell all of your electricity?
So wind farms out there today have been built on business cases where they have to waste energy, presumably because the infrastructure for green hydrogen is not in place.
Arguably yes, but also we've seen the cost of that energy that they generate drop rapidly. What we're talking about here is opportunity for them to further improve the returns on those turbines and overall reduce the cost of renewable energy. It's not just due to hydrogen or the use of hydrogen on trains or in other vehicles. Hydrogen has been investigated pure and simply as an energy store to give us seasonal protection. So for the days when there is no wind energy and no sun, and we are dependent on that renewable energy generation, if it so happens we've stored that energy as hydrogen, we can convert it back and keep the grid powered using a gas. I think that's another element of flexibility that potentially combining technologies of hydrogen and renewable electricity generation. There are many synergies there that I know the people we talk to when we talk to them about hydrogen are looking at.
Right, and presumably that conversion back can either be a fuel cell or a hydrogen engine or whatever other technology they create.
Yes, or indeed it could be fed into the gas network in due course and used to heat homes or cook with or for industrial purposes.
Right. Interesting. And lastly, before we move on to the next section, I know you were quite strong in saying that these new trains with these existing trains with these new power facilities installed, the performance characteristics of the train is made to match the existing rolling stock out there.
Basically, yes. Again, with any stored energy on board a train, you can probably go as fast as you like and accelerate as quickly as you like. And you see that with all the electric cars that are coming out at the moment. Incredible performance figures. But of course, performance like that doesn't combine well with range. you're using a lot of your energy to accelerate very fast. So you're far better off to drive your electric car as if it were the car you always had previously, at the same rate of acceleration, the same speeds in traffic, and you'll get a better range. Same applies to the train. We match the performance of the train to the timetable necessary, and we can offer some improvements over the original performance of diesels, but there's always a trade-off. So you want to offer what's needed, what's appropriate, without deciding to make some kind of very, very fast. I don't think we'll find these trains with a ludicrous mode.
No, none time soon. And I guess you don't want half the rolling stock being twice as fast as the existing rolling stock out there. That would put pressure on the network, wouldn't it? So.
Well, a very good point. Yes, I mean everything's run to a timetable on the rail network. There's no point having huge performance exceeding what the timetable requires or can facilitate.